Okay, this video is on the atomic radius of elements or the sizes of atoms. So basically, what we're going to discuss in this video is how do the sizes of atoms vary? And if we're talking about an atom of one element versus an atom of another element, are the atoms the same size? Is one bigger? Is one smaller? And how do we know? And what are the underlying ideas that kind of reinforce that? Like what causes one to be bigger or smaller than another one? Okay. So the first thing we're going to look at is this idea of the trend within a group. So remember, your groups are the ones that go up and down on the table. And so I'm going to do an example of lithium, who's right here. Oops. And francium, who's right here. Okay. So I want to know, or what I'm going to discuss is one of these things bigger or smaller than the other one? So how would we even begin to answer this? So if I were to write lithium's electron configuration, and I'm going to use the noble gas configuration, it would be helium, and then it has one electron in the 2s, whereas francium, holy cow, you wouldn't want to write francium's electron configuration, would you? Francium's would be radon, and then it has one electron in the 7th level, in the 7s. Okay. So, these things have these two elements have a couple things in common. They each have one valence electron. However, lithium's valence electron, or its last electron, right, that we encounter, is in level 2, and francium's is in level 7. Well, what do we know about the energy levels? Well, the higher the energy level, the farther it is from the nucleus, right? So how can I write that? A higher, yeah, that's good. Higher energy level. Energy levels are located farther from the nucleus. Think about that picture that you used to draw when you were in, 8th grade. Here's your nucleus, right? Here's the first level. Here's the second level. So there's lithium's electron, right? And if you were to say, okay, that's how big lithium would be. But think about francium, level 3. I'm not even going to have enough room. Level 4, level 5. Oh my gosh, level 6, level 7. Oh, there's francium's electron, and look how much bigger francium is just because of the fact that its valence electron is located in the 7th energy level, and that is much farther from the nucleus. Okay, so if I were to draw these like in comparison, lithium might look like this, and francium's going to look like that, right? It's going to be much larger. So when we're talking about the sizes within a group, okay, the only thing we look at is energy level. So let's make kind of a bold statement here, and I'm going to say higher energy level equals a larger atom, right? Y, of course, is the kicker, and we'll say because those electrons are located farther from the nucleus. So if I had to draw an arrow on my periodic table to represent the group trend, they're small near the top of the table and they get larger near the bottom. So I'll write smaller and then larger. Okay, and so that would go for anything. So, I could give you a second example. And I can ask you, who's smaller? Magnesium or iodine? Now, I picked two who aren't in the same group, but that's okay because I want to reinforce this idea. So we think about where they are. Here's magnesium, and here's iodine. Okay, so what are we looking at? We're looking at their last energy level. Remember, that comes from here, right? So magnesium has electrons in level 3, Iodine has electrons in level 5. So this time I asked who's smaller, right? The answer would be magnesium, because its electrons are located closer to the nucleus, okay? So when we're talking about within the group, we're talking solely about what energy level they're in, and that's all there is to that discussion. However, life gets a little more complicated when we talk about within a period. So be kind of open-minded here. Let's talk about lithium and fluorine. Now I picked those two because we already identified where lithium is on the table and fluorine's right here. Okay, so let's talk about these. Well, lithium, 1s2, 2s1. Fluorine, 1s2, 2s2, 2p5. Okay? In both lithium and fluorine, their valence electrons are in the same level. Right? In this case, it's level 2. So, if we tried to use the same reasoning that we did up here, talking about what energy level the electrons are in, you might be inclined to say, well, maybe lithium and fluorine are the same size, right? Because they're both in level 2. Okay, and at that point, maybe that's what you think, and that's okay. They're not the same size, and so we have to look at something else. So I'm going to make a statement. So when the electrons are in the same energy level, the size of the atom depends on the number of protons. We'll talk about why. Okay. So try to think about this. This is hard teaching this on a video, so I'm going to do the best I can. So if I was going to draw lithium, okay, right now I'm going to say that in the nucleus for lithium, I have a positive 3. Okay, because lithium has 3 protons. And I'm just going to draw like that. We'll say that's the second level, okay? Well, we know that fluorine has 9 protons, and its electrons are located also in level 2, which should be approximately the same distance from the nucleus as I drew lithium's, right? Level 2, level 2. However, what we have to think about is which atom here, who is pulling those electrons. I'm going to use the word like harder, stronger, okay? Remember, electrons are negative, protons are positive. There's a huge attraction. So these protons in the nucleus, right, they're pulling on those electrons, and they're trying to bring those electrons closer. So, and remember, lithium and fluorine both are starting from the same kind of place, energy level 2. Pretty much same distance from the nucleus. So the question is, who can pull stronger? Fluorine can. It's got more pulling power. Oops. So because fluorine has more protons, which I like to talk about as being the pulling power. It's almost like fluorine has more people on the tug of war team, okay? It's got more to pull with, and because it can pull harder, it's going to pull those electrons in closer, which is going to be a smaller atom. This is kind of a tough thing to understand. Lithium has fewer protons, less pulling power, okay? So it's going to be a larger atom. So if I were going to draw a comparison of these two, maybe lithium would look like this, but fluorine is going to look like that. Okay, so in this case, the period, this is the smaller side, and this is the larger side. So it increases like this. Now this is hard. Don't get me wrong. This is tough. Let me do another example as one more practice. All right, so let's say we had, I don't know. let's see, we had beryllium and carbon, and I want to know, who's larger in size? Okay, so we have to think about their electron configurations. They're both in the same period. Okay, so beryllium is 1s2, 2s2, and carbon is 1s2, 2s2, 2p2. So both have valence electrons in level 2. Okay, so then from here we have to look at protons. So I can draw my picture if you want. So with my protons, beryllium has 4 protons in the nucleus, and we'll say here's level 2. And carbon has 6 protons, so it's not a whole lot more, both in level 2, right? So they initially we think, oh, they might be the same size, but we're looking at what was my question? Who's larger? So larger means less pull, okay? Because think about it, if you're pulling not as hard, then the electrons aren't going to come as close. So because beryllium has less pull from the nucleus, 4 instead of 6, it's going to be the larger atom, okay? Because maybe beryllium pulls its electrons to like right here. And so then my atom will look like this in size, okay? But carbon, who's got 2 more protons, maybe carbon pulls its electrons to here. And look what happened, right? Who's larger? Beryllium. Okay, so one more bold statement here, because this is where life gets tricky. We only base size on number of protons if the valence electrons are in the same energy level. Okay, so what do I mean by that? So if I ask you about barium and bromine, okay, so if we look up at the table, we see that barium has, barium's in the 6th level, right? Barium's like right here. Oops, oh my gosh, it's way up here. Barium's like right down here. And then bromine is in level 4. Okay, so this was like the first thing we talked about. So what is always going to predominate is the energy level. So in this case, we're not even going to talk about protons because the 6th level is farther from the nucleus than the 4th level. And so barium is larger and bromine is smaller regardless of who's got more protons. See, because what happens is barium has more protons, but it can't outdo the fact that barium's electrons are farther from the nucleus to start with. So this is huge, okay? This is a really big discussion that we only are going to talk about protons if they're in the same energy level, and they weren't here. I had level 6 versus level 4, so my reasoning is going to go back to energy level, and this discussion is kind of over.